to name a function that is an equation so we're not looking at a graph, we're not looking at ordered pair, we're looking at an equation for this function. That lists the input and the output. When we talk about the input, what letter or what variable are we talking about? X, good. The input, X. And the output, which is Y. Nice. It's kind of a long definition there, so take your second, write that down. All right, so as we take a look at this, if I write a function, let's call it function f. That's usually a go-to name for a function because function starts with the letter f. And then in parentheses, we're going to show x, meaning when I put x in to this function f, what am I going to do with the x? I'm going to do x plus 2. So f is the name of the function. X is called the input, which we should know that already. And then the x plus 2, we'll call that our rule. What is that function rule? What are we doing with that information? Okay, so for example, if I put 3 into this function, 3 is my input, what would my answer be after I put 3 into this function? My rule tells me when I have an input, I'm going to take that input plus 2. So 3 plus 2, 5. Okay, if you need to write that 3 plus 2 there, so you remember that that's what we did. Okay, so it's a way for us to say, as we're doing math, it's a way for us to say what we're putting into the function and what we're getting out of the function. To have that ordered pair, because an input is really what letter again? X, and our output is really Y. Good. All right, I'm going to draw a line across here just to show where we're starting with our examples. That was kind of the overall idea. We do have 5 examples today. Which feels like a lot, but once we do this, you'll be like, that was not that bad. I promise. All right, our first one, we're going to have function k. And then we do the parentheses x. The way that we say this out loud is we say it as k of x, which is a little bit different than what we're used to. So when you see that k parentheses x, we say that as k of x, meaning we're putting x into the function k. Omar, bro. Put it away. Okay, and k of x is going to be 6x plus 7. We're also going to have another function m. And we're going to say m of x equals 2x squared minus 4. Okay, and again we would say this as m of x. That's how we read it out loud. So m of x equals 2x squared minus 4. This is where I'm going to use my two color pencils. I'm using green and orange today. If you'd like to use green and orange, you can, or you can use two other colors. I'm going to use orange for this k. And I'm going to use green for the m. Because as we work today, we do have two separate functions. We have a k function and an m function. All right, so we have 5 problems we're going to do today. All of our directions are going to say to evaluate. Evaluate just means to find the answer. All right, so number 1, we're going to evaluate k of 6. So k, and then that of 6 means in parentheses 6. And that tells us we're going to put 6 into the function to see what we get out. Which function am I going to be putting it into? Function k or function m? Okay, how did you know? Yeah, literally just says k there. Good. Okay, so we're putting it into function k. So function k starts off with 6, and then it says x, so I'll do parentheses for x, because that's what we've been doing with those quadratics, plus 7. That originally was x. What are we putting in for our x? What's our input? 6. So we're doing 6 times 6 plus 7. So what is 6 times 6? 36. Plus 7? 42. 43. So as a full sentence, we're going to put this all together where we say k of 6 equals 43. And that tells me a lot of information. It tells me which function we used. We used function k. When we put 6 into the function k, what do we get out? 43. All right, number 2. I'm going to just put it off to the side here because we have 5 problems. I know I don't want to run out of space today. All right, number 2, we have k of negative 32. And we have to find that answer, k of negative 32. So first step we need to do is decide which function are we putting it into, k or m. K, how did you know? It literally tells you k. Beautiful. So we're taking k. I like to personally write it as 6, and then instead of x, use parentheses, plus 7. And we're putting in a new number in for that x. What are we putting in for that x? Negative 32. Now, we could show our work here and do it just like how we did the other one, or we're kind of at the point with Desmos that we can just type this whole thing in. So 6 parentheses negative 32 plus 7. And we know that k of negative 32 equals negative 185. All right, we got 3 more problems. All right, number 3. Oops. All right, number 3, we have m of negative 3. So this time, which function are we using? You guys are so smart. So that's kind of the nice part with function notation is we can have multiple functions going at the same time, multiple rules, and you should be able to know which rule we're using each time because it's named. This one name is M. This name is K. They don't have fancy names like Kaylin and Fatima. They just are named M and K. All right, so for M, we have 2x squared minus 4. So I'm going to write 2. And again, anytime we see x, we want to use those parentheses, especially when we see an exponent. That squared has to go on the outside minus 4. And what are we putting in for the x this time? Negative 3. How are you facing backwards and writing down notes? Must be really complicated. All right, so in my calculator, I'm going to do 2 parenthesis, negative 3, parenthesis, don't forget the squared, minus 4, and our answer is 14. So m of negative 3 equals 14. That tells me a lot of information. Which function did we use? What did we put in? And what did we get out? 14. All right, number 4. We have 2 more. We have number 4 and then number 5. We're going to step it up a little bit here. Do you guys feel like you kind of understand the basics here? You get it? Okay, this time we're going to say m of 6 minus k of 2 plus 4. So this one's telling me to do kind of a lot. Okay, first thing it's telling me to do is I need to find the answers for m of 6 and k of 2. So this first one I'm using function m. The second one I'm using function k. So I'm going to find those answers first. So for m, I'm going to zoom out for a second, sorry. We have 2x squared minus 4. So we'll say 2 times something squared plus minus 4. And what are we putting into our m? 6. Well, we're putting in 6. What do we get out?
68.
Yeah, you're getting the whole answer there. So 2 times 6 squared, whoops, minus 4. Our whole answer is 68 for that first one. Okay, I'm going to do a little dashy line or a squiggly line. That way I can keep track. I'm going to do k of 2 now. So remember, k is a different function that's telling us to do 6 times x plus 7. So 6 times 2 plus 7. That one we can probably do without a calculator. Or if you use a calculator, that's fine. 6 times 2 is... Well, 6 times 2? 12, thank you. 12 plus 7? Cool, 19, crushing it. All right, so we're going to rewrite this problem. This isn't the answer yet. They're asking us to find m of 6, which we found the answer. What was the output for m of 6? 68. Then it says minus k of 2, which when we put 2 into the function k, we get out 19. And then at the end it says plus 4. Okay, and then we're just plugging that whole thing in. We can put it in our calculator. We can do it left to right. 68 minus 19, then plus 4. But it's a Monday, so why would we do it in our head if our calculator just does it? And our answer is 53. Now you're probably sitting there like, why the heck are we learning this? We actually do this a lot in math where we use multiple functions and we have to plug in one thing to one function, another thing to another function. Now these functions are usually more complex. They're usually talking about interest in your bank accounts or your interest that you're paying on your student loans. Or they might be talking about population and doing things multiple times for different populations as one thing grows and one thing decreases, how that works. All right, we have one more problem, number 5. This one's a little different. Last one. Number 5, we're going to do k of x plus 3. So this time, I want to know if I change all my data points, all my inputs, if I increase all my inputs by 3, what is the actual function that I'm going to be doing? Because I won't be doing the 6 times x plus 7 any longer. It'd be different. So we're going to use function k. All right, function k tells us 6 times x plus 7. So I'm still going to do 6, parentheses, a little bit bigger parentheses than our normal, and then plus 7. This time in the input part, in the parentheses, we have an x plus 3. So I can't actually evaluate this one. I'm not going to get to one answer. I want to simplify it, though. Make it easier to work with. So as we take a look at this problem, how can I simplify this? What could I do to make it easier to work with? This goes back all the way to I-2, our second lesson of the whole year. How can I get rid of these parentheses? Multiply, good. What's that property called? Pew. Pew, distribute, good. So 6, if you need to rewrite this, because it's been a while since we've done it, 6 times x, and then we would do 6 times 3. Do we need to do 6 times 7? No. Nope, not in the parentheses, good. So what's 6 times x? 6x plus 6 times 3. And then we still have a plus 7. And then what's our last thing that we're going to do to simplify that? What parts can I combine? Yeah, the 18 and 7. Those are our like terms. So we'd get 6x plus, what's 18 plus 7?
26.
25?
35?
Just 25. So much work, you guys. All right, so we'd write it as k of x plus 3 equals, and again, that tells us a lot of information. It tells us now that if we use function k, but we increase all of our x's, or all of our inputs by 3, rather than doing 6 times x plus 7, we could just do 6 times x plus 25. Okay, so that is our function notation. Tomorrow we are going to pause for our practice.